Today we're going to talk all about distance, slope, and midpoint, three formulas that you need to have memorized and you need to be able to use. This is all dealing with coordinate geometry. So the distance formula that we have is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. What we want to keep in mind is x1 comma y1 is a coordinate or a point, x2, y2, again, those are both going to be points. So what you need in order to use this distance formula is 2 points. So for this example here, we have finding the distance from A to B. My suggestion would be start off by labeling your coordinates x1, y1, x2, y2 until you get really used to this formula. That way there, when you go to plug it in, it'll be a little bit easier to keep track of the coordinates. So we first start off with our x2, which is 4, minus x1, which is 1. Close the parentheses and square it. To that we add y2, which is 6, minus y1, which is 2. Close parentheses and square. Now just be careful with your orders of operations. You want to simplify within the parentheses first. So 4 minus 1, we get 3 squared. 6 minus 2, we have 4 squared. Now we still want to square each of those parentheses. So 3 squared, we get 9. To that we add 4 squared, which is 16. So when you add 9 and 16, we currently have the square root of 25, and this is a perfect square. This will simplify down to a distance of 5. So the distance between those 2 points we know is going to be 5 units. Okay, our next formula that we have is our slope formula. And slope we can say is a ratio, so we want to think something to do with division, of its vertical rise to the horizontal run. A lot of times you'll hear change in y over change in x. The formula is y2 minus y1 over x2 minus x1. So again, this is going to be our rise compared to our run. Okay, and again, we're using 2 coordinates just like we did in the distance formula. So when we're evaluating this, what is the slope of a line that passes through these 2 points? Again, suggestion would be start off by labeling x1, y1 and x2, y2. And it doesn't matter the order. The thing that does matter is that the 1's come together and the 2's come together from one coordinate. Okay, so we're going to start by calculating. So we have, for our slope formula, y2, which is negative 8, minus y1, which is negative 6. Now be careful with your signs. So we have a negative 6 that has to stay a negative 6. We're going to divide that by x2, which is negative 5, minus x1, which is 7. So when we simplify this, in our numerator, we have negative 8 minus a negative 6. So that's really like plus a positive. So negative 8 plus 6, that's going to give us negative 2. And on the bottom, we have negative 5 minus 7, which is going to give us a negative 12. Now, the one thing you always want to remember, and you might want to make a little bit of a note to yourself over here, is you want to always reduce your slopes. The other thing you probably want to keep in mind is you want to keep it in a fraction form. I know sometimes we get into the habit of trying to write this as a decimal, but we want to keep this in a fraction form. So if we go to our calculator and we get our fraction template and we type in a negative 2 divided by a negative 12, it's going to get us a decimal, which that's okay. But if we go to our menu button and we go to number 2, which is number, and we go to number 2, which is approximate to fraction, and press enter, that will help reduce your fraction. So that's going to tell you negative 2 over negative 12 really reduces to a negative 1/6. That's always a good check to make sure that when you have reduced your slope, you've actually reduced it correctly. So now different types of slopes that we get. We get a positive slope. The way you get a positive slope, again, if we're thinking fraction, two different ways. I could have a positive number divided by a positive, or if I have a negative divided by a negative. Both of those result in a positive slope. And positive slopes, when you read your graph, should always point up to the right. To get a negative slope, again, two different ways. You could either have a positive number divided by a negative number, or a negative divided by a positive. And again, when I read my graph going left to right, I'm going to have a downward pointing arrow down to the right. For a zero slope, okay, the way we get a zero slope is either 0 over a positive number, any positive number, or 0 over any negative number. And now a zero slope is going to be a horizontal line. Okay, so one way you can remember that is if I think of that letter Z for 0, I can take a look at those lines. Those Z's, that line is showing me that horizontal line that might help you remember. And then an undefined slope, well, that's going to be the reciprocal of 0. So that's any number over 0 or any negative number over 0. And our undefined slope is a vertical line going straight up and down. So again, maybe a way to help kind of remember would be if I look at that U, that tail on that U is showing you that's an up and down line. Might help trigger a memory on this. Okay, so that's our slope. And now the next thing that we have is, well, what happens with the slope? What does that tell us? Well, that can tell us something about parallel lines and perpendicular lines. Parallel lines, first off, we have some symbols to connect with this. Parallel lines, your symbol is going to look like two parallel lines. They will always have the same slope. Okay, and graphically speaking, they're never going to intersect. With our perpendicular lines, we have an upside down looking capital T. Their slopes are going to be negative reciprocals. That's a fancy way to say when you have your slopes, you want to think flip the numbers and negate. So if one's positive, the other's negative, and vice versa. If one's negative, the other's positive. These will intersect to form four right angles. So our question that we have here is we have two different lines. We have line M and we have line K. And it wants to know, are they parallel, perpendicular, or neither? Well, if I'm seeing these two words here, parallel and perpendicular, that's making me think slope. So what I want to do is I want to actually calculate the slope of line M. So let's do that first. And we're going to have, how about y2 minus y1 over x2 minus x1. And when we simplify this, it looks like in my numerator, I have a -1. In my denominator, I have a -3. We always reduce slopes. We always keep it in simplest forms. And simplest forms would tell us that that's a positive 1/3. So we do the same for line K. So I want to find the slope for line K. And again, if we plug this in, so now I have y2 minus y1 over x2 minus x1. And we want to think again, simplify, so my numerator is a -7, my denominator is -2, and we always want to have this in simplest forms, which gives me positive 7 over 2. And now I'm going to compare these slopes. So if they were parallel, they would be the same slopes. They would have the same value. So I have to say it's not parallel, and I'm going to use my symbol, because the slopes are not the same. Well, I have to say it's not perpendicular because my slopes not, I could either say flipped and negated, or real technically, I could say they're not negative reciprocals. So what that means is our lines are neither. Now, if they're neither, well, then they're intersecting somehow, but they're not forming four right angles. Okay, and our last formula that we have is our midpoint formula. So just like it suggests, it's a point in the middle. To find something in the middle, we want to think average. So I want to add up my two coordinates and divide it by 2. So we do the average of the x's, get a new coordinate, and then you get the average of your y values. So we're adding in this formula. Okay, so again, we have QS, it has a segment, it has endpoints, and we want to find the coordinate of its midpoint. So again, until we're really comfortable, let's label them x1, y1, x2, y2. Maybe give yourself a visual. So I have segment QS, and I'm trying to find point M, the midpoint. Okay, so we're going to start by adding. So I have 3 plus 7 divided by 2, so average of the x coordinates. Put a comma because we're going to make another coordinate, another ordered pair. We're going to do the y's, so I have 5 plus a negative 9 and divide that by 2. Okay, so again, we simplify. So 3 plus 7 gives us 10. And 5 plus a negative 9 gives us a negative 4. And now if I take this one step further, 10 divided by 2, we're going to have 5, comma, negative 4 divided by 2, I have a negative 2. And what that has now found is that middle point of segment QS. And so now we know where M is located. Different way you could see this question, still midpoint, but slightly different. What if we have the endpoint? What if I already know where A is located? A is located at negative 3, negative 2. And I know where M is located. M is located at the coordinate 3, 4. That's my midpoint. I need to look for the other endpoint. The other endpoint, that's A is an endpoint, M is my midpoint. That means my other endpoint's got to be somewhere on that side. And I have to find that. So we could use the formula. We could also do a little bit of counting and thinking, well, if M is in the middle, then the distance from one coordinate to the midpoint has to be the same as the distance from the midpoint to wherever the other endpoint is. So I'm going to start with my x coordinates and say, okay, so from a negative 3 to a positive 3, I have increased by 6. So what that means is I'm going to start at my midpoint, and I want to think, okay, if I increase another 6, well, that's going to bring me to my new location. So 3 plus another 6, that's going to give me 9. Okay, we're going to do the same thing with the y's. So I'm going to go from my negative 2 to a positive 4, and I see, well, that also increases by 6. That's a little bit of a coincidence that they're the same. But I do that process again. So now I start at the midpoint at 4, and I think, okay, I need to add again another 6. So 4 plus 6 brings me up to 10. So now if I go to my graph over 9 up 10, well, I can see point B, that's where my other endpoint is. So I hope you found this helpful. Just going over some of the basics, and if you like it, give me a good like and subscribe on my YouTube page. Thanks so much.